Okay, now members, let us see a new topic. This topic is called number bases. It's very easy and very interesting. Let us see what we mean by a number base. Number bases are different ways of using a number. Stop writing down numbers. So you can use one number in different ways. You can use a number in base 10, which you can give it different in base 8, you can give it different in base 7, and so on. The most common base is base 10, and it's called sometimes called the decimal base. Other common bases include base 2 binary base, base 3 trinary base, 8 octal base, 12. Now 12 is beyond 10, so we say dual because of 2, then decimal because of 10. So 12 plus 10 plus 2 get the 12. So duodecimal base, then hexa 6, hexadecimal base 16. Digits of a number in a given base are all less than that number. So all digits of a number in a given base should be below that base, strictly below that base. All numbers without bases, without a number with all numbers without a base, without bases, this is without bases, are base 10. And also here, in number bases, digit 10 is represented by T and 11 by 8. So whenever you say T, means they are giving you digits, these two digits. And then whenever you see E, you see the figure will be 11. Let us go through these ones and see what happens. Now, converting from any base to base 10. How do you convert from any base to base 10? What we do, you give these numbers power 0, 1, 2, 3. Now what you do, you get this times the base power, this power here. So now this will be 1, the figure here, times the base which is 2, power 3. Then plus 0 times 2, the base power 2. Then plus 1 times 2, power 1. Then plus 1 times 2, power 0. So these are powers to the base. Then you multiply with these digits there. Okay, this will be 1 times 8 plus 0, and now multiply. You multiply with the 0, you get 0, then plus 2, then plus 1 times 2 power 0. Remember, 2 power 0 is always a 1. So this will give us 8 plus 2 plus 1, and this will give us 11. Now this will be in base 10. Okay, when you come to this, now you start, we have E and T. In simple terms, we first handle this. So E, we say the E is 11. Then T is 10. That's how you handle this one. Then this is base 3. So this will be, you give it power 0, 1, 2, 3, and 4. So this will be 2 times 3, then power 4. Then plus 1 times the base power 3. Then plus 1 times the base power 2. Then plus 1 times 3 power 1. Then plus a 0. Because this will be 0 times anything which will give us 0. So this will give us, this is 81. 2 times 81 plus 1 times 27 plus 3 power 2, that will be a 9. Then 1 power times 3 power 1, that will be a 3. So you multiply this, you get 2 times this, you get 62. 162, then plus 27, then plus this and 9 plus 3. Then there you just get your calculator and press that value onto a calculator. When I get mine, I press 126 plus 27, then plus that 12. I get 2, 0, 1. Now this will be base 10. Simple as that. Then when you come to this, you see it's base 5. How will you handle this? You will say this will be now, this will give it powers 0, 1, 2. So now 3, 4, 2, base 5 will be now, the first is 3, then times the base, which is 5, then power 2. Then plus, the next is 4, times the base power x, which is 1. Then plus 2 times 5 power 0. Okay, this will be 25 times 3. That will be 75. Then plus 12. Then plus any number to power 0 is 1. So this will be 5 power 0 will be 1. So 1 times this you get a 2. Okay, so this is 14 plus this, you shall get 89. So this will give us 89 and it makes 10. So you can try out this. Okay, then when you come to this, now how do you convert from base 10 to any other base? Okay, dividing the number repeatedly by the required base. So that number we are converting to base to any other base, we divide it with the required base we want to convert to repeatedly until the remainder is a number less than the base. Until the number is less than the base, the remainder is in a reverse order gives the number the required base, as we are going to see. Let us read this. So we are converting 64 to base 10. Base 10. We said any number without a base is to base 10. So what you do, you come out and you draw your simple table like this. You put your 64 there. Then you indicate that here you're writing the remainders. Then the base, the one that's to convert to is a 3. So divide this repeatedly. What you do, you get a closest number, of 3 close to this. The closest multiple of 3 close to this is 63. So 63 divided by 3 will be 21. Then you say 21 times this will get 63. Then when you subtract this, the remainder will be a 1. Then you still divide by 3. This goes here, 7, the remainder is 0. You divide until the remainder is strictly less than the base. So by 3 here, 3 goes here, 2 times the remainder is 1. Well, now you start this 2 is less than this. There you stop. It means that now your 64 will be, now you keep these ones in a reverse order like this. It will be now 2, 1, 0, 1. Now this will be now in base 3. When you come to this now, 21, 10 to base 2. What you do, you get your 21, you draw a table, then you put here the remainder. So we are to convert to base 2. So now, 2 goes here 10 times. 10 times this, 20. 21 minus 20, you get a remainder 1. Then by 2 goes there 5 times, the remainder is 0. Then by 2 we get here 2, remainder 1. Then by 2 divide until is less. So by 2 this is 1, the remainder is 0. Then we pick them in this order like that. Our now 21, 10 will be 1, 0, 1, 0. 1. Now this will be the base 2. Now I think that we can write different numbers. I think this one we were talking about. Writing a number in different forms. So see that now 21 in base 10 is the same as 10101 in base 2. This in base 10 is the same as this in base 3. So please try out this. I wish you well.